Hello friends, I am Goutham Krishna B, a student of class 9th from Silver Hills Public School. I am here to present before you the 11th chapter of our science textbook, Work and Energy. The portion I am going to deal with is the rate of doing work or power. So let's start with looking at the objectives of today's session. So today's objectives are: what is power, the unit of power, average power, and the commercial unit of energy. And at last we are going to deal with some examples given in our textbook itself. So let's not waste time and start our session. So what is power? Power is defined as the rate of doing work or the rate of transfer of energy. So if a question is asked, define power, the answer that you will be giving is power is defined as the rate of doing work or the rate of transfer of energy. So what does this power do? Power actually measures the speed of the work done, that is how fast or how slow work is actually done. So now let us derive the equation for power. If an agent does work in time t, then the power is given by. So this is the first equation that you have to study in this chapter, that is power is equal to work done by time taken, which is P is equal to W by T. Here which is power, which can be denoted as capital letter P, and work done, which is denoted as capital letter W, and time taken, which is equal to T. So that is the first equation that you have to study in this session, that is power is equal to work done by time taken. So the next point, the unit of power is watt, and 1 watt is equal to 1 joule per second. So here the unit of power, so we studied that power is equal to work done by time taken. So the unit for that is watt, and that 1 watt is equal to 1 joule per second. The unit of power, watt. And do you know from this watt came? Watt is actually given in honor of the famous scientist James Watt, and watt is denoted as capital letter W. The 1 watt is the power of an agent which does work at the rate of 1 joule per second. We can say that power is 1 watt when the rate of consumption of energy is 1 joule per second. 1 watt is equal to 1 joule per second, and 1 kilowatt is equal to 1000 watts, and 1 kilowatt is equal to 1000 joule per second. The power of an agent may vary with time. This means that the agent may be doing work at different rates at different intervals of time. Therefore, the concept of average power is used. We obtain average power by dividing the total energy consumed by the total time taken, that is average power is equal to total energy consumed by total time taken. Now what is the commercial unit of energy? The unit of joule is very small and hence very convenient to express very large quantities of energy. So we use a bigger quantity, that is 1 kilowatt hour. Now what is 1 kilowatt hour? Let us start with an example. Consider a machine that uses 1000 joule of energy every second. If the machine is used continuously for 1 hour, it will consume 1 kilowatt hour of energy. Thus 1 kilowatt hour is the energy used in 1 hour at the rate of 1000 joule per second, which is 1 kilowatt. And 1 kilowatt hour is equal to 1 kilowatt into 1 hour. Here 1 kilowatt, which we studied earlier, is 1000 watts, and 1 hour when converted to seconds is 3600 seconds. So when we multiply 1000 watt with 3600 seconds, we get the answer as 36 lakh joules. In standard form, it can be written as 3.6 into 10 raised to 6 joules. 1 kilowatt hour is equal to 1 kilowatt into 1 hour. Here 1 kilowatt, which we discussed before, is 1000 watt, and 1 hour, which is converted to seconds, is 3600 seconds. So when we multiply 1000 watt with 3600 seconds, we get the answer as 36 lakh joule. So in standard form, it can be written as 3.6 into 10 raised to 6 joules. 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joules in standard form. The energy used in households, industries and commercial establishments are usually expressed in kilowatt hour. For example, electrical energy used during a month is expressed in terms of units. Here 1 unit means 1 kilowatt hour. Now let us move on to the exercises given in our textbook itself. This is exercise number 1, which is example 11.7 in our textbook. Two girls, each of weight 400 Newton, climbs up a rope through a height of 8 meter. We name one of the girls A and the other B. Girl A takes 20 seconds while girl B takes 50 seconds to accomplish the task. What is the power expended by both the girls? So here the data given are, there are two girls and both of them weigh 400 Newton and the height of the rope is 8 meter, and we will name both the girls as girl A and girl B. And girl A took 20 seconds while girl B took 50 seconds. So now we have to calculate the total power expended. So the power expended by girl A, the weight of the girl as per the question, it is 400 Newton, which will denote it as mg is equal to 400 Newton, and displacement, which is the height, is 8 meter, and total time taken t is 20 seconds. Now let us find the power expended by girl A. The weight of the girl is 400 Newton, which is mg is equal to 400 Newton. Displacement h is equal to 8 meter, that is the height of the rope, and total time taken, the girl A took 20 seconds, so t is equal to 20. So now we are using the first equation, that is power is equal to work done by time taken. P is equal to mg h by t. Here mg is 400 Newton, h is 8 meter, and t is equal to 20 seconds. When we multiply 400 Newton with 8 meter and divide it by 20 seconds, we get the answer as 160 watt. Now let us calculate the power expended by girl B. Here the weight of the girl is 400 Newton, the displacement, that is the height, is 8 meter, and total time taken is 50 seconds. Power is equal to mg h by t. Here mg is 400 Newton, h is 8 meter, and t is equal to 50 seconds. So when we multiply 400 Newton with 8 meter and divide it by 50 seconds, we get the answer as 64 watt. So the total power expended by girl A is 160 watt and the power expended by girl B is 64 watt. Now let us look at the second example. An electrical bulb of 60 watt is used for 6 hours per day. Calculate the units of energy consumed in 1 day by the bulb. So there is a bulb that uses 60 watt of energy and it is used 6 hours every day. So they are asked to calculate the units of energy consumed in 1 day by the bulb. So the power of the electric bulb, which is 60 watt given in the question. Now we are converting that into kilowatt. So to convert watt into kilowatt, we have to divide it by 1000. So here it is 60 watt and we are dividing it by 1000 and we get the answer as 0.06 kilowatt. Energy is equal to power into time taken. So here power is 0.06 kilowatt and time taken is 6 hours. So when we multiply 0.06 with 6 hours, we get the answer as 0.36 kilowatt hour. As 1 kilowatt hour is equal to 1 unit, 0.36 kilowatt hour will be equal to 0.36 units. So the total energy consumed by the bulb is 0.36 units. Now let us summarize today's session. The equations that we studied in this chapter are: power is equal to work done by time taken, 1 watt is equal to 1 joule per second, 1 kilowatt is equal to 1000 joule per second, average power is equal to total energy by total time taken, 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joule, 1 unit is equal to 1 kilowatt hour, and energy is equal to power into time taken. The main definitions from this part is: power is defined as the rate of doing work or the rate of transfer of energy. 1 watt is the power of an agent which does work at the rate of 1 joule per second. Average power is calculated by dividing total energy consumed by total time taken. I hope you understood the concepts clearly. Thank you.